From our previous lesson, we learned that probability is the likelihood or unlikelihood of an event to occur. And we also said that probability ranges between 0 and 1. And when the probability is closer to 0, it is less likely to occur. And when it is closer to 1, it is more likely to occur. Now, let's talk about mutually exclusive events. Now, two events A and B are said to be mutually exclusive when the two events cannot occur together. Now, let's take an example. Suppose we take a coin. The sample space of a coin is what? A head or a tail. Now, for a coin, it can either show a head or a tail. Now, if this is a coin, okay, and this is the head, and this is the tail, and I toss it, there is no way the coin will show both the head and the tail. The two events cannot occur together. So that is what we mean by mutually exclusive events. Now, let's talk about independent events. Independent events. Independent events. Now, two events A and B are said to be independent when the occurrence of one does not affect the occurrence of the second one, or does not affect the occurrence of the other. So, assuming I have, let's say, a die, 1, 2, 3, 4, 5, 6. That's the sample space for a die. Now, suppose I throw this die and the die shows a 5. Okay? Now, if the die shows a 5, now on my next throw, and I throw it again, maybe if I throw it again, it shows another 5. Now, I'm saying that the probability that I threw this die to show the first 5 does not affect the occurrence of this first 5, does not affect or does not influence the occurrence of the second 5 here. These two events are independent events. Now, it is also likely that when I throw it, it will show a 5, and then it can show a 1, or it can also show a 2. So these two events are independent events, so that the occurrence of the first event does not have any influence on the occurrence of what? The second event. So these two events are said to be what? Independent events. Now, let's talk about the sample space of an event. The sample space of an event. Now, when we talk about the sample space of an event, it is the set of all possible outcomes of a given experiment. So the sample space is the set of all possible outcomes of a given experiment. So just as we did for the coin, when we have a coin, the sample space of a coin, let me use coin, one coin, we have the head or the tail. When we have two coins, okay, it can either show head, 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 tail, tail, head, and then tail, tail. We can also have three coins, having head, 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 tail, tail, head, tail, 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 head, and so on and so forth. Then we can also talk about, let's say, a die. So we have a die. The sample space for a die is 1, 2, 3, 4, 5, 6. We can also get the sample space for throwing two dice. With that one, we have to draw a table. We have 1, 2, 3, 4, 5, 6. Another 1, 2, 3, 4, 5, 6. We have 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, and so on and so forth. Now, let's talk about the sample space for, let's say, a standard deck of cards. So a standard deck of cards. So for cards, a standard deck, we have 52 cards. We have 52 cards. That's the sample space for a standard deck. So where we have the king, okay, we have 4 types. You know, the normal cards we play. We have what we call the hearts. We also have the spade. We also have the club. And then we also have, oh, this is the diamond, okay? And then we also have hearts, diamond. We have the hearts. Let me write it. We have the diamond. We have the club. And then we have the spade. Now, are they? Oh, this one, no, those boys, we call it yet. Kalo, Charlie, I've forgotten, but Charlie, who knows? So in each of them, this is red in color. This is also red in color. This is black, and this is also black. Now, for each category, we have the ace, the king, the queen, the jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 times 4. Okay, 13 times 4 will give us 52. So in a standard deck of cards, we have 52 cards with the ace, the king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. It ends at 2. So this is our standard deck. So the same thing happens here, here, 2, and here. So when you multiply by 4, you get 52. So this is our sample space for a standard deck of cards. Now, let's look out for the probability of an event.